Okay. I once again all of you welcoming the lecture series of electric power quality. You know that we are in fifth chapter. We are already discussing the how this distributed generation plants, as small generating plants, is helpful to improve the power quality. Now today our topic for discussion is so DC, nothing but distributed generation on low voltage distribution networks. How the performance whenever our DC is added to the low voltage distribution networks. What is the performance of that DGs? How that network is activated, or how that network is acted whenever you are adding some DC to that network, distributed network. Okay, all the things we are going to discuss in this one. Okay, this is very interesting topic today. Now see this, you know that very well. So, so this DC, adding the DC. Remember, whenever you are adding this DC on a very complex nothing but a low voltage distribution. Okay. So before we proceeding to add the DC to this low voltage network, first of all, you have to know that what is this low voltage distribution network, how this low voltage distribution network is formed. When you have to understand this formation of low voltage distribution networks and all other things, then protective schemes of this low voltage networks, then after we can move further adding DC to this type of network. What are the complex issues while erasing, while you add the DC to this network, then how to overcome those drawbacks, then how to add this DC to this network to improve the power quality and all other things. Okay, we'll cover in this topic today, if the time permits. Okay, now see this. So first of all, you know that you have to know that what is a low voltage distribution network. Okay, so now see that when you try to see this, the low voltage network is nothing but this is one type of the network operated in the some large cities and other things, large areas in the network. Okay, so now see this low voltage network is converted into the or is subdivided into the two parts. The secondary network. Okay, the secondary network are a street network. Remember this low voltage network is subdivided into the two parts. What is the first one? The secondary network, or you can also call it as a street network. Remember the street network. Then the another one is a spot network. A spot network. Our analysis is based on this one, a spot network. Mostly our analysis is based on spot network. So now see this. What is this spot and secondary networks? How this networks? So all these networks are derived from the radial feeders, radial network, radial network. Okay, remember all these networks are derived from the radial network. A secondary or spot network are nothing but a radial, but a low voltage, radial networks. You know that what is the advantages of radial network? What is the advantages of radial network? By connecting our any of the distribution network in radial way, so the continuity of the power you maintain at any instant of time, whether there is any fault in any one of the feeder, so the other feeder will supply the power to the source. That is the advantage of the radial feeder. Okay, that is one of the main advantages. Okay. Okay, now see this. What is this secondary network or street network or spot network? We are dividing low voltage network into the two categories. Now see this. What is the two networks? A street network and secondary network. Okay, a street network and secondary networks are from two or more primary distribution feeders through the integrated transformer breaker protection combines called a network unit. This see this, you can see this this secondary network or spark network, how these two networks are formed. Okay, na? Okay, now see this, these two networks are formed by because of they are formed by using some different types of primary feeders like this, a primary feeders like this, where these primary feeders are located are where these primary feeders are divided. Now see this, now see this, now this is the transformer. Now see this feeder, no this is the feeder. Yes, this is, so the primary feeder is now see this is the transformer, is located at this substation, is located at this substation. So this entire network we can call it as the network units. Okay, so this is one type of the network, this is one type of the network. Okay, so how this network is framed or form this network based on the number of primary feeders and secondary feeders added together. At the same time, you have to maintain some protective schemes at the substation, then form the network and call it as the network units. Then what is the secondary network? And now you see this, what is the how to form this. Then what is the secondary network and what is the spot network? A secondary network is the nothing but a street network. Yeah, the name itself, a streets. So this supply the power to the some streets, some local areas and all other things. So we call it as the secondary network. Then what is the spot network? The spot network is nothing but can supply the power to a large type of the buildings. Okay, a commercial buildings, right? Okay, a shopping malls like that, a commercial buildings, large power required buildings, are a small type of industries. Okay, you can supply the power using this. Okay, okay. So these are the two types of the network: secondary network as well as the spot network. Okay, what are the two networks? Secondary network are a spot network. Okay, secondary are spot network. See this, what is a secondary network? A secondary network are also called as a street network. What is the meaning of the street? These secondary network are supplying the power to the small areas. Like in our areas, like in Eluru, in our area, like Annarpeta or Rararpeta, like that areas. That is the secondary network. You know what is the primary network? You understand that what is the primary network here? Network, nothing but a network unit is nothing but the primary network. What is the primary network here? So this network is at the substation, at the substation. So on that substation, you are subdividing into the some different secondary networks, subdivided into the different secondary networks. You know that name a secondary network. This secondary network is nothing but it can supply the power to the small streets, small areas, and like that. Okay, what is the spot network here? A spot network is nothing but this is also a small type of the network. You can supply the power to the direct power to the as large type of the buildings and all other things, a small industries like that. That you can call it as the second this part. Okay, so what is the main objective of these networks? Why you are dividing a secondary network and a spot network, or primary network to the secondary to the spot and all of this? What is the primary objective? Here, the primary objective or primary aim is to okay maintain the uninterrupted power supply. Nothing but you can maintain the you can given the continuous power to the consumers. That means we are achieving the power quality, high power quality. You can see this, that means we are achieving the high power quality. Okay, to maintain the high power quality, but to given the you see this to achieve high service reliability means here to maintain the continuous power to the consumers. We are giving continuous power to the consumers, and that may be increases the service reliability. So to achieve this one, to improve the power quality, to given the continuous power to the customers, to achieve this one. So a primary traders, just see this type of primary feeders networks is taken different types of the substation. This is substation 1, this is the substation 2, this is the substation 3, this is substation 4. That is the basic aim of the radial feeder. A radial feeder is nothing but this one. Can given the can supply the power to the consumers by using the a different type of the substation. No, so for suppose this substation fader, a fader is got fault, getting some fault. The remaining three substations will supply the power. That is the advantages of the radial fader to improve the power. A simple that one, not a very big issue. Simple that one. Now our aim is that our intention is that here how to add this DC to this low voltage network. Okay, before that, now see this in this diagram. See this diagram, S part network arrangement. You see this S part network arrangement here. Okay, this is the network unit. Remember, this is the network unit that is available at the substation. At the substation. At the substation. So from the substation and all other things, so this is the switchgear unit that is available in the substation. So in this network, so one of the feeder is taken here like this. So these are the likewise another different types of the networks. So all the things were added here. See this some another feeders, some different feeders to form the, see this is the radial. This is the radial. You know that this is the radial network. This is the area you can farm this this network is used for the spot network arrangement. Is nothing but some directly connected to the some heavy loads at the same heavy loads. So this is some substation 1, substation 2, and substation 3 for suppose. So these are the some networks, some different feeders, feeder 1, then feeder 2, then feeder 3. They farm, you can farm this radial distribution network to maintain. If any one of the feeders got fault, so and the feeders, the feeder 2 and feeder 3 will continues to given the power to the customers. So that's why we are not facing any power failure issues and all. So that is the advantage of this type of. So under this one, you have to see this what is the fundamental operation of this network. A low voltage distribution network fundamental operation. You know that fundamental operation of this network. Then after you can add the DC. Now this we are not at all adding this DC. Remember, we are not adding the DC right now. You just know that what is the fundamental operation of this network. What is the fundamental operation? You know that. So this is one type of the radial network. This is one type of the radial network. This may be of smart or second network. What the only difference between the smart network, secondary network, or street network is nothing but the depends on the loads and depends on the area which you are going to given power to the customers and all other things. Okay, this is one type of the radial network. One type of the network. Here you can see this. So after this three feeders, feeder 1, this is a primary feeder, and secondary feeder, and third feeder. What would it be? Are feeder 1, feeder 2, and feeder 3. You just simply this is substation 1, substation 2, and substation 3. You can given power to this loads and all other things. This type, this side, you may think that this side there are some loads and all other things. Okay, S1 and S2, S1 and substation 2 and substation 3 and all. So you are giving some continuous power to the customers. So now see this a critical arrangement in this type of feeders, radial distribution feeders or the radial network feeders is the switch gear. A switch gear is nothing but a protective equipment. Remember, a protective equipment, a switch gear or a protective equipment. Okay. Okay. First of all, what is the operation of this network? For suppose if out of these three feeders, feeder 1, feeder 2 and feeder 3, there is a fault here. For suppose there is a fault in the feeder 2, the customers are experiencing any power interruption? No. So the remaining two feeders is nothing but, what are the remaining two feeders? So the feeder 1 and the feeder 2 will continue to supply. So this feeder 1 is open, this feeder 1 is open, this feeder 1 is open. Sorry, that one. This what is this one? This fader 2 is open because we are assuming that there is a fault in that fader. Yes, this fader 1 is open. Or suppose this fader 1 is open. Open. You see this open. So this is disconnected because if there is any fault, some relays. So who senses that fault? A relay senses that fault. Relay senses that fault and given it to the circuit board and given it to this CD. So this is circuit board. So that circuit breaker is separated from this network. So to this fader from this fader. So whether the circuit breaker is separated to this feeder from this network, what will happen here? So the total loads is driven by the remaining feeder 1 as well as the feeder. Okay, so now see this, if there is any fault, now see this, these are also circuit breakers, these are also the some circuit breakers. See this circuit breakers. These are also the some circuit breakers. Now see this, and each and every feeder and each and every network, now see this, and each and every network units is nothing but substation network units have its own switchgear equipments to protect their feeders, to protect their feeders. So this 5 feeder has different network combinations of protective equipment at the same time secondary and as well as though. You are not assuming that here our analysis is that so these three feeders are coming from the three different substations. So that's why these three feeders have a different type of protective schemes, but you know that in our India especially, so each and every substation will do follow the some same kind of a protective schemes, okay, to protect the systems. Okay, so three different three separate protective schemes. Fader 1 has separated protective scheme is there. Fader 2 as well as the fader 3. If fader 2 is identified that this substation relays will identify the fault in this fader 2. So so that relays and protective equipments is open that fader from that network. So this fader 1 and fader 2 will supply the power to that. So what is the which one senses the fault here? The relay will sense the fault. Then what is the function of that relay? You know that a relay functionality is very important in the power system protection. When that relay is failed to operate, you can that may be possible to shut down the entire power system. Or entire grid failure also happen in some cases. So the relays plays a very crucial role while protecting the devices. That relays, we have the relays also different categories of the relays, different types of the relays, overcome relays, earth fault relays. At the same time, reverse directional relays, some different types of the relays are there. At the same time, different technologies are there to extract the faults on that relays, faults on that lines. What are the different types of the relays? Nothing but some artificial intelligence based relays are there. At the same time, nothing but fuzzy logics based relays are there. At the same time, microburst based type of relays are there, but most oftenly we are using the electromagnetic type of the relays because of the cost issues. Okay, okay, now see here the network relay. Here we are taken here that what is the sensitivity of the network relay? 0.1% rated power of the transformer network. If 0.1% change in that 0.1% change the parameters of this feeder or transformer values, transformer output fader parameter values, this relay is activated 0.1%. 0.1%. Why? But you know that this is very sensitive. By putting the relay value, or you can trace the relay values. 0.1% is very sensitive values. Very sensitive values. That but if you decrease the sensitivity of that relay, okay, so 0.01%, if you can increase 0.5%, what will happen here? So plus or minus that percent is occurred in the system, then after the relay is operated. Otherwise relay is not operated. By putting the lower the values, the sensitivity of the relay you may increases. The sensitivity of the relay increases, so it may be causes some problems also. So you know that we are already seen some topic here, the reach of the relay. Whenever you are adding a DC here, for suppose DC here, the reach of the relay is changes obviously. You can also keep it in mind while adding DC to that nearby the relay locations. The reach of the relay, nothing but the sensitivity capability of the relay is reduces by adding the DC directly to this place. Okay, that is the another issue here. So but here how to add this relate to this this we will discuss in later. Now see this the network operation here presently. So the relay operating or sensitivity is fixed to the 0.1%. Why you are fixing that much lower levels? A small change in, remember, a 0.1 percentage change in voltages or current levels, the relays are operated. That's a very sensitive level. Why? Because we are fixing the relays to the very sensitive means here, because the network protector must operate for all type of the faults on the primary failure, including the ground faults. This is the reason. This is the reason why we connected the this relay, or why we tune this relay to the very sensitive levels, means this is the reason for any type of the fault, for all type of the faults, including the earth faults. If the relay is senses that one and given the commands to circuit breaker, and it will operate. Okay, but whenever you see this, whenever we are tuning that relay to the very sensitive values. So on the type of the network, for suppose we are adding DC here, it is somewhat difficulty for the operation. Remember now this, see this point. So now see this reverse power function. You see this, what is the function of that relay here? So this is the reverse power relay. When there is some fault in the system, it can observe that reverse power in this line, so it can relay will operate. That is the function, that is the operation of that. So because of this reverse function means that is no DC can be added to the network with the intent to export power to the UPS system. And no DC is added because of the sensitivity. Remember the sensitivity level, how much, what is sensitivity level? 0.1% is the sensitivity level. Whether you add the DC, that sensitivity level is decreases to the 0.5% or 0.7. These are the some trial and error based values. I might say that this is the correct value. But the reach of that relay, the sensitivity of that relay is decreases. Sensitivity of the relays decreases to the 0.5 or 0.7 or 8 or 9%, and so on. So we may assume that, so the 0. By fixing the 0.1% means we are not at all adding the DC to the this type of the network. Remember, there is one point here, a primary point. So which type of relay we are assuming here? Which type of relay we are using? An electromagnetic relay. It basically operated the you know that what is the time period here? At 0.1% is the current value, the measured current value. Then what is the time period here? What is the time here? So it can operate at 0.05 seconds or 3 seconds. Because this is the 50 seconds. Our frequency. Sorry, this is the 60 hertz. This is the 60 hertz because we are discussing in the US system. This is the 60 hertz. Or you may think that 3 cycles. You may think that 3 cycles in a 50 hertz cycle. You may calculate it the time period. You know that 1 second you have 50 cycles in Indian system. 50 cycles in the Indian system. You can calculate it there. But 3 cycles, what is the time? What is the time? You can calculate that. So here this 0.05 seconds is not the Indian specified time, specified frequency. That is a US because that frequency is 50 hertz. So this time for in our India, this time is also reduces because that our frequency cycles is 50 cycles per second. So the year this is time is for 60 hertz and nothing but 60 cycles per second time is this one. Okay, now see this here we can increase the performance of this relays. We can increase the performance of this relay. We can increase the performance of this relay. Okay, what is the relay we are assuming here? An electromagnetic relay because of the cost issues and other things. So to increase the performance, we can add the microprocessor based relays, microprocessor based relays. Or some nowadays, most of the power system they are using microprocessor based relays. Whenever then artificial intelligence as well as the fudge. If these two are working, if these two are need to work based on the microprocessor. If the microprocessor is not available, these two are no use to develop. Okay, so here nowadays an artificial intelligence based as well as fuzzy based systems are also used to protect the systems. Okay, so different types of the relay combinations are there. Different types, electromechanical relay or electromagnetic relays, as well as microprocessor based relays, artificial intelligence based microprocessor based relays, then fuzzy logics and microprocessor based relays and all other things. So whenever you are going this microprocessor and the further category of the relays, we have more choices, more options to tune this relays. Okay, okay, okay. Yes, see this they have the more flexibility and new features whenever you are going for the microprocessor type of the relays and further advanced type of the relays. What is the advantage here? You have more flexibility and new features. What is the new features is nothing but the tuning of this relays. Tuning means the setting values. The also it can also measure the previous values. It can also calculate the previous values, then as well as the present values. Can compare the intensity of that problems and all other things. That is the artificial intelligence as well as microprocessor based. We are already studied in the I mean switchgear and production also. Okay, so now see this what is the most critical design while this type of network form this type of network is nothing but the the characteristics of almost all network protectors in service is that they are not intended to separate two parallel electrical systems. Therefore DC can never be allowed to island a network. What is the meaning of this one? A network protector as a prevents analysis. What is the intention? Our so this we can form this type of critical network. The protective scheme aim is to protect the network from the different types of the faults. That is the primary aim, and not for the to separate the fader from this another fader from this network. This is the meaning of this. So our aim is to protect the system, but not the our intention is to separate the fader from this network. This is the point. Therefore, a DZ can never be allowed to island this network. Can never be allowed. This type of network combinations, remember, this type of protective schemes were used here. So this is difficult to add the DZ to this network, this network. But our intention is to add the DZ. But our intention is to add the DZ. You understand this type of network, this type of sensitive network, relaying network. How so it will be not to add the DZ real, but how to add this DZ to this net to improve the power quality. Okay, we may be discussed in the next. Okay, okay. Thank you. That's it for today. Thank you for joining the class. Tomorrow we will discuss the how to add the DZ to the networks. Thank you. Thank you for joining.